Greetings everyone, this is not an expert here, back again with another video. Today we are going to be solving problem number 44 and the difficulty it's been rated at is medium. This problem was asked by Google and let's just get down to it. So we can determine how out of order an array A is by counting the number of inversions it has. So two elements AI and AJ form an inversion if AI is greater than AJ but I is less than J. Basically, a smaller element appears after a larger element. What we're just trying to say is that whenever you sort of encounter throughout the array, if you encounter an element on the right hand side which is less than the element on the left hand side, that is an inversion for us. And what we have been given is an array and we need to count these number of inversions. The only thing what sort of makes this problem really unique is the fact that you want to do this at time complexity less than of n square. We can assume that each element in the array is distinct, and we've been given an example that if you have an array 2, 4, 1, 3, 5, you can see that the number of inversions it has is 2 and 1 as a pair, 4 and 1 as a pair, and 4 and 3 as a pair. So basically we need to return 3, and that's the number of inversions it has. Cool. So fortunately, we were able to find a similar problem on LeetCode. And again, I would sort of urge you to, pause this video and check out the link given in the description below and try solving this problem on your own if you can. But all in all, whenever you're given an, a question like this in the interview as well, the best part about this is that, the number of restrictions which they have given you, it sort of helps you get a few clues as well. So when they talk about n log n, you know for a fact that you can't do two loops and just, do iterations on that and just get the number of inversions. What you need to do is you need to come up with a more smarter approach. And this is actually pretty easy for you to visualize as well, because basically what you're doing is you're trying to see what are a number of swappings or iterations which would take place in order for you to, entirely sort out an array. But we'll stop over there for a while. We'll just go through what the problem description is on LeetCode. It's pretty much the same, but the only difference here is the fact that instead of just finding out a number which is greater, a left number which is greater than a number on the right, what we need to do is we need to find whether it is twice greater than the number on the right. So basically nums I, if it's greater than 2 into nums j, that's an important reverse pair. And you can see over here is the difficulty it's been rated at is hard, and we've been given an example over here where you have 1, 3, 2, 3, and 1, and the output is 2. The reason for that is that the iterations which are happening is 3 and 1, which is over here, and again 3 and 1 over here. Again, it needs to be greater than twice the number of the rightmost value, and that's something which we have to remember. Cool. So again, if you sort of visualize this, you can think of a better approach, and most of the solutions which you'll find online would be using some sort of a data structure or rather something which you already know of. And the approach we'll be using today would be a divide and conquer approach. So one thing which sort of comes to mind when we sort of think about a divide and conquer approach is basically, think about something like merge sort. So the way merge sort works, and again, you can check out the link which I've given in the description below, and I'll try to put in, and hopefully you should see something on your right which visualizes how merge sort works as well, and you can sort of go through it as well. But basically what we're going to do is we're going to go through a divide and conquer approach where we're going to break down our problem into multiple subproblems and move on from there. One of the best part about merge sorts is the fact that when you break it down, you already assume a few things like the subarray which you have would be already sorted by the recursion which has already happened before. So if you sort of look at an example, and we'll take the same example which was given to us, or rather let's take a better example. Let's take 165, 2 and 9. Let's say that this is the array which was given to us. So if you sort of divide it, you can see it can be divided as 165 and 2 comma 9. This is the way it will be divided, right? And this is just a recursive call for us to divide in separate subarrays, right? But what's more important over here is the fact that when you have 1 comma 6 comma 5, you know for a fact that it's it sort of needs to get sorted. So when you sort of go ahead with this entire solution, you know for a fact that 5 and 6 are going to be swapped together. And let's just, for the sake of clarity, let's just do that. And let's just say 5 comma 6 is something which is going to be divided as well. And that's not going to really help us with the formulation, to be very honest, but I'll get to the formulation, which is more important to us. So till now, the number of inversions which we'll have is basically 1. That's basically because we've swapped out 5 and 6. But just so that we are clear, you sort of take two indexes. One will be the ith index, which will be on the left hand side, and one will be the jth index, which will be on the right hand side. And the way it will sort of go is, let's say I is equal to 0 and j for fact is equal to 3, as you can see here. So this is the 0th index, this is the first 1 index, and this is the 2 index, and this is the 3 index, right? So j is equal to 3 over here. And when that happens, the way you sort of go through the entire iteration is that you try to, go through all the elements. So you check for whether 1 is greater than 2, it's not. So you go to the next element on 1. Then what we do over here is we find that 2 for a fact is actually less than 5, and it's actually the twice of 2 is also less than 5. So what we need to do in that case is that we need to come up with an approach to understand how many elements are basically going to be inside this. What we can do is we can keep on going with the iteration, but basically we can come out, because we know for a fact that in this subarray this thing is already sorted out, right? So we know 1 comma 5 comma 6, this particular subarray is sorted. And if we're encountering such an element, then for a fact that all the elements after I, like I equal to 2 till it hits j, all of them are obviously going to be greater than 2. So the way you can sort of coordinate versions are basically by saying, if you take a middle element, so let's say a middle is some value, and basically what we'll do is middle minus I would be the index that you want to get, or rather it'll be the collection of all the indexes which you've gotten so far. So it'll include 5 and 6 over here, and then you can go ahead with the computation. Again, this is pretty easy to understand, and again you can sort of break it down on your own. And there are multiple approaches to go about it, so I won't force this particular approach because most people have difficulty with the divide and conquer approach. But let's just try to go about it, right? So again, as we always start, we start with our base conditions and we say, hey, if nothing has been given to us, we will return 0. And now what we'll do is we'll basically call a utility function. So let's just do that. We'll do return merge and count. Let's just call it a merge and count function. And we need a few things which are pretty obvious. We need the nums, which have already been given. We need 0, and we need the last value or nth value, and that's just so that we are clear on it. And why I'm pasting in these two things, if you didn't understand why I'm doing this, I'm using a merge sort approach. So the way a merge sort approach works is basically you push in the array and you push in the low and the highest index. So your low is the 0th index and your high is the nth index, the last index rather. So what we're going to do is we'll create our functions. Let's do that. Let's do def merge and count, and the array which has been supplied to us, and the starting and the ending index. Now, if you know what how merge sort works, it's awesome. This should be very easy for you. And if you don't, it's pretty easy. You just say, hey, if your start is equal to end, you need to do a return. Or basically, if it's greater than equal to end, you can do return. So we'll just do return 0. And we'll be assuming for a fact that merge and count is going to return a number. So that's what we're using over here as well. So if that happens, you return 0. And the next thing is we'll just maintain a variable as count and a simple variable as your mid. So mid is basically going to help us split out our entire problem into multiple subproblems. So let's just do that. Let's just do start plus end divided by 2. And the reason why I'm doing this is basically sort of converts it into a better representation so that I can query it easily. Now what I'm going to do is I'm going to assume that merge and count is going to return a number, and it's always going to return the count, the number of inversions it's found so far. So all I have to do is I just have to say count needs to get appended, merge count. So we'll just do merge count over here. And now we just break our problem into, two different sub problems. So we'll just do from start to mid. And the next thing would be from mid plus one to our end. So let's just do that. Let's just do mid plus one plus end. And basically what we've done is we've subdivided our problem. Now, we've not really come up with the approach of, counting the number of inversions which are there. And that's actually pretty easy to do. But before we do that, let's just declare a few more variables. Let's just call a left variable, which will be start, and a right variable, which will be mid plus one. And the reason why I'm doing this is basically because of how we're going to do the iteration. And like I explained before, the way our entire process is going to go is we're just going to find a particular element where our rule or the condition which sort of dictates that a particular pair is an important reverse pair, whenever that happens, we'll break out of that loop, right? So that's what we want to do. So what we'll say is, while the left index is less than equal to mid, and again, so let's just put a comment over here. So let's just say this is the left index. Whoops, I'm sorry, force of habit. So let's just say this is the left index, and this is the right index, or rather, right index subarray. Sorry. Yep. So basically, when I say right index, it means the right subarray index, and when I do left index, what I mean is left subarray index. I'm just commenting it over here so that you understand what it is, right? And now what we're going to do is, we are just going to go through a while loop, and we're just going to say while left is less than equal to mid, and right is actually less than equal to end. When that happens, when it sort of breaks out, it'll break out. But now what we have to do is we just have to check for that particular condition. So whenever we encounter a condition, whenever we encounter a match for a reverse pair, we will increment the right index. And whenever we don't, get that particular element, what we'll do is we'll update the left index. So let's just do that. We'll just say, hey, if nums left is greater than 2 into nums right, then basically this is an important reverse pair, and the count is basically going to be updated by the formulation which we came up with, which is mid minus left, and we'll do be valid pairs obviously, and we need to count those elements. And now all we have to do is we need to increase our right pointer, so we'll just do right plus equal to 1, and if there is not a match, what we'll do is we'll just increment the left index. And that's basically the entire operation that you want to formulate in order for you to count the number of inversions. Now, what most blogs or what most websites would tell you to do in order for you to solve this problem is perform an entire sorting. But fortunately, in Python, there's a sort function which you know for a fact will run at a worst place complexity of n log n. So we will just sort of leverage that. But if you want, you can sort of implement your own approach. I'm not really going to do that because that's just going to take a lot more time. So we're just going to hey, we need to sort this from nums start to end plus 1. And basically what's going to happen is it's going to sort all elements from start to end, and now we just return count. Again, I would sort of help you understand this entire operation could sort of take place when you're doing the merge operation, or rather the operation where you make a temp variable and sort of push all those values inside a sorted array and then return the sorted array. You could do all that stuff, but we're not really going to do it because our sorting can easily be handled with this thing, and that's not really the crust of the problem. It's not a sorting question, to be very honest with you. This entire thing is what is more important to us. And the way you sort of do splicing in Python is that when you give a start index, that's the index that is going to be included. But when you do end, if I do end plus 1, it's going to include end as well. So for that reason, I've done end plus 1 so that the end index can also be included. So whatever value that you're getting, it's basically getting sorted out and then it's getting pushed back up. And that's basically it. There's nothing more here, to be very honest with you. Let's just run this code. And awesome, you can see that this is running fine. It's giving the same output as expected output. And all you're doing over here is we're just using a divide and conquer approach where you have a start index and an end index. Basically, you can help partition your entire array into a left array and a right subarray, and then you can move forward from there because of the entire divide and conquer approach. So all in all, you just maintain the left index for the left subarray and the right index, and then you've just gone through it and the entire iteration forward with it. And for the daily coding problem, you won't really put the 2 multiplied by nums, right? That's not really important because this is just for this particular problem. We would remove that, but the entire logic still remains the same. Cool. Let's just submit this. Hopefully it should get submitted. And awesome, you can see it's faster than 82% of the Python online submissions. And memory wise, it's not that great, probably because of the recursive call stack. But all in all, it's a pretty good solution. Awesome. Again, if you had any comments or if there's something that you didn't understand, you can leave it in the comment section below, and I would love to handle any of your queries. And if you did like this video, do give a like and do subscribe to this channel. We are discussion over here, and we would love to have you on board with us. Again, if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.